First, let's see what is multivibrator. Multivibrator is a circuit that switches between two states, that is high state and low state, right? Multivibrator is a circuit that switches between two states, high state and low state. Now, let's see why it is referred to as astable multivibrator. Why it is referred to as astable multivibrator? There is no stable state and that's why it is referred to as astable multivibrator. This astable multivibrator is also referred to as a free running oscillator. Now, astable multivibrator, it is used to generate square wave and hence it is also called a square wave generator. The principle behind this astable multivibrator is the operational amplifier operates in saturation region. In case of astable multivibrator, the output voltage is fed back to non-inverting terminal of an op-amp as well as inverting terminal of an op-amp. Right? So, what is the basic principle behind this astable multivibrator? In astable multivibrator, the operational amplifier operates in saturation region. Okay. So, now let's see to the circuit of astable multivibrator. Okay. So, as I said before, the output voltage is fed back to the non-inverting terminal of an op-amp as well as to the inverting terminal of an op-amp. Okay. So, initially, let us assume the output voltage is equal to the saturation voltage. If the output voltage is equal to the saturation voltage, what happens is, at the non-inverting terminal of an op-amp, the voltage is beta into V saturation. As a result, now the capacitor starts charging. The capacitor keeps on charging. Now, at a particular time instant, the voltage across this capacitor exceeds the voltage in the non-inverting terminal of an op-amp. Once the voltage across the capacitor exceeds the voltage in the non-inverting terminal of an op-amp, now the output voltage V0 becomes minus V saturation. The output voltage V0 becomes minus V saturation. Now, if the output voltage V0 is equal to minus V saturation, now what happens is, at the non-inverting terminal of an op-amp, the voltage becomes beta into minus V saturation. That is minus beta into V saturation. Now, if the voltage across the non-inverting terminal of the op-amp is minus beta into V saturation, what happens is the voltage across the capacitor starts discharging. Okay, the capacitor, it starts discharges, it keeps on discharging till it reaches a voltage greater than minus beta V saturation. Okay. So, once the voltage across the capacitor is minus beta V saturation, what happens is, now the output voltage becomes plus beta V saturation. Now, if the output voltage is equal to plus beta V saturation, what happens? The voltage across the non-inverting terminal of an op-amp is equal to plus beta V saturation. Now, again what happens? The capacitor starts charging and it keeps on increasing. Okay. The capacitor starts charging and it keeps on increasing. Now, if the voltage across the capacitor is greater than or equal to beta V sat, what happens? Now, the output voltage is equal to minus V saturation. Okay. So, like this process repeats and finally we get a square wave at the output. Okay. So now let us see the same concept using waveform. Okay. So this is the square wave that gets generated using Astable Multivibrator. Okay. So as I said initially, the output voltage V0 is equal to V saturation. If the output voltage V0 is equal to V saturation, what happens to the voltage across the capacitor? The voltage across the capacitor, it increases. Okay, that is the capacitor, it charges. Okay, so the capacitor keeps on charging and once it reaches the voltage beta V saturation, this is the voltage nothing but beta V saturation, that is nothing but the reference voltage. Once it reaches the voltage beta V saturation, what happens? The output voltage, it switches to minus V sat. The output voltage, it switches to minus V sat. Okay, if the output voltage, it switches to minus V sat, what happens? See, the voltage across the capacitor, it starts discharging. Once it discharges and reaches the reference voltage minus beta V saturation, what happens? At this point, the output voltage, it switches from minus V saturation to plus V saturation. Okay. So like this, the process continues and it results in generation of square wave. Okay. So now we are going to see how to derive the time period of this Astable Multivibrator. In order to get the time period of the Astable Multivibrator, let us write the expression for voltage across the capacitor. The voltage across the capacitor is expressed as Vc of t. Vc of t is nothing but the voltage across the capacitor. Vf. Vf is nothing but the output voltage plus Vi. Vi is nothing but the input voltage. Input voltage means it is nothing but the voltage at the inverting terminal of an op-amp. Minus Vf into e power minus t by Rc. Rc is the time constant. Right? Now, initially we are assuming that the output voltage V0 is equal to V saturation. Already we saw if the output voltage V0 is equal to V saturation, what is the voltage in the negative terminal of an op-amp? It is equal to minus beta V saturation. Now we have to substitute what is Vf and Vi in this equation. Substituting Vf and Vi in this equation, we got it of this form. Okay. So now what we are doing is, we are taking V saturation as common. If we take V saturation as common here, it is 1 minus, already we have taken V saturation as common. So it is 1 plus beta into e power minus t by Rc. Now, what we are going to do, we are going to find what is the voltage across the capacitor at time instant t is equal to t1. Okay. So let us see to the previous slide. At time instant, at this time instant, what is the voltage across the capacitor? Okay. This is the first time instant, right? At this time instant, what is the voltage across the capacitor? It is plus V reference. Plus V reference is nothing but it is beta into V saturation. Plus V reference is nothing but it is beta into V saturation. Okay. So at time instant, at the first time instant, what is the voltage across the capacitor? It is nothing but the reference voltage, that is nothing but beta into V saturation. Okay. So now that we are going to substitute here. Okay. So Vc of t at time instant t1, Vc of t is equal to Vc of t1. It is nothing but beta into V saturation. The voltage at time instant t1 is equal to beta into V saturation. Okay. So since Vc of T1 is equal to beta into V saturation, we got it of the form beta into V saturation is equal to V sat into 1 minus 1 plus beta into e power minus T by Rc. Okay. So this expression we got by assuming that at time instant t is equal to T1, the voltage across the capacitor is equal to beta into V saturation. Okay. So now simplifying this expression, we got the time period as T1 is equal to Rc ln 1 plus beta by 1 minus beta. Now this time period we have calculated for half cycle. Okay. So for full cycle we have to find the time period. It is nothing but T is equal to 2 into T1. Okay. So 2 into T1. So already we found out what is T1 here, right? So what is T1 here? Rc ln 1 plus beta by 1 minus beta. So we got the time period of astable multivibrator is 2 Rc ln 1 plus beta by 1 minus beta. Okay. So let me tell you the principle of astable multivibrator again. The astable multivibrator makes the operational amplifier to operate in the saturation region. Okay. So initially we are assuming that the output voltage V0 is equal to plus V saturation. If the output voltage V0 is equal to plus V saturation, the voltage at the non-inverting terminal of an op-amp is plus beta into V saturation. Now at this time instant, the capacitor starts charging. Once the capacitor starts charges, and if it exceeds, that is if it is greater than or equal to beta V saturation, what happens is V0 becomes negative. If V0 is negative, the voltage across the non-inverting terminal of an op-amp becomes negative, and at this instant the capacitor starts to discharges. If the capacitor discharges more than minus beta into V saturation, then again the voltage becomes positive. Like this the process continues and it results in generation of square wave. Okay. So